Thank you for the nice words. First of all, my thanks to IPPTA for giving me the opportunity to share the, the best practice of the cement industry. And also I came here to listen the best practice of the paper industry of India, which actually is an inspiring story for the cement sector. So before I move to the topic, I wanted to touch upon what are the challenges for the cement sector. I think cement is the second material after the water, the highest consumption. If you calculate the cement and water, cement and concrete, that is the highest consumption after water. What is the consumed material? So cement currently in the world produces close to 4.5 billion tons of cement. In India, we produce close to 400 million tons of cement and have a very high carbon footprint of almost close to 600 kgs. Means if we say 240 million tons of CO2 coming from the cement sector, if you think about India's carbon footprint annually, we contribute almost to 8 to 9%. So there is a big challenge, like we are all hard to abate sectors, but I think paper industry is one which actually guiding force for us. And many paper companies are already carbon positive. We are far away from that. And what is that we can learn from the paper industry in terms of CO2 mitigation? One of the basic problems the cement industry is having is the raw material, the limestone. For every ton of clinker we produce, almost half a ton of CO2 is released from the calcium carbonate. And how to mitigate this? This is something which is, until unless we shift from the limestone to produce cement, and this CO2 cannot be eliminated. And other part is the fuel, which is all of us, the fossil fuels are being used extensively for the fuel purpose. And the third element is the electricity and the transportation. And cement had a very large carbon footprint for the transportation also, close to 30 kgs of CO2 per ton of cement transported to the customer, both inbound and outbound logistics. So what we are actually looking into is how we can address if we think about sustainability challenge for the cement sector, I consider that the raw material security. First of all, even whether the CO2 challenge is not there, India has only mineable limestone reserves of close to 90 billion tons. The 90 billion tons, based on the current production rate and increase, maybe in the next 30 years, most probably by 2050, India will be starving for the limestone. So and we cannot mine on the forest, we cannot cut the mountains, and also we can go for the limestone into below the sea. So looking into the mineable limestone available is only suitable for the next 30 to 40 years. Now, resource conservation is something which is required and which is also connected with the CO2 goals of net zero. So cement, currently what we are looking is that explore what are the ways where our raw material we can substitute limestone with the industrial waste like fly ash, pond ash, lime sludge from the paper industry, steel slag, non-ferrous slag, copper slag, zinc slag, many slags which are actually whatever is the inventory on the ground, and also what is not is actually going to be produced, how we can use it, and can we replace the limestone required with the clay, calcined clay, so that our limestone requirement comes down and our carbon footprint we can reduce. In terms of the fuel, basically our objective is currently we use 70% clinker and 30% other materials. Our objective is to go down to 30% level of the clinker content and 70% substitution materials for the raw material requirement. In the process that we can extend the life of our mines to 100 years. So this is one of the objectives in terms of sustainability, that raw material security for the future. In terms of the fuels, we see that approximately whatever we produce, 15% of the cement production we require fossil fuels. Now we are actually moving towards the alternative fuels, let it be biomass or RDF or industrial waste, plastic waste, any waste streams which ultimately can be fed into the kiln, because cement kiln is a green incinerator where it can actually neutralize all the toxic gases, chlorine, fluorine, and no, or nitrogen, any element which ultimately they become calcium chloride, calcium sulfate. All this becomes the substitutes of the, so they can get into the clinker and permanently. So that you don't need to send this material to any landfill. Third element is the power. The electricity which you require, the cement manufacturing process generates close to 35 to 40% of the power requirement from the waste heat recovery. Almost all cement plants in India are actually have the waste heat recovery. And in the process and the balance is how we can use the renewable energy, whether it's a wind or solar or hydel or biomass energy. In this particular area there, I see that look upon paper industry. Paper industry is producing the plantation for their raw material requirement. And we need to produce for the energy requirement. So how we can collaborate and ultimately see that we substitute the entire fossil fuel requirement of the cement kiln. In fact, I feel that there should be the technical committees of Cement Manufacturing Association and technical committees of IPPTA has to work together and do a giant collaborative work in the process, that some of the new areas where we can collaborate, and in the process that it will help both the companies in terms of the minimizing the fuel requirements, fossil fuel requirement. The other aspect where we can contribute for the paper sector is the water positivity. Indian cement industry is ZLD, zero liquid discharge, and also many companies are already 10 times water positive. Some companies have aspired to become a 50% water positive, 50 times. So there is an area where water is a challenge for the paper industry, how we can actually do collaborative work in terms of the water harvesting structures in these surrounding areas where we will be able to harvest water more than our requirement. That's in terms of water security for the community and also to our plants, and also try to create livelihoods using the water, and also for the plant irrigation and plantation. Other area is about biodiversity. So you are doing the plantation for the purpose of your raw material, and we are doing plantation for the purpose of energy requirement. But we require to see that what is the issue of biodiversity, how we can actually enrich the biodiversity coming out with the multi-species plantation in the process that we enhance the biodiversity. That's one of the area also we can actually work together. And for our advantage that on the water and biodiversity, we have mines. Mines is having a huge pits of, for storage of water. Using that water, we will be able to create the afforestation and try to improve the biodiversity. So this is one area which ultimately is also area of collaboration. If we come to the most important aspect is the cement industry's biggest challenge is if you are using limestone, CO2 is inevitable. What you do with the CO2? What we are actually trying to see, can we convert that CO2 to a fuel? Can we convert into a byproducts of hydrocarbon? So some of the pilots in cement sector is happening on production of hydrogen, and then producing carbon, doing carbon capture and getting pure form of CO2, and mix the carbon, CO2 and the hydrogen, and try to produce hydrocarbon. Let it be methane or it be methanol, and we can actually produce liquid fuels. So what are when we are emitting huge amount of CO2, and how we can actually transform ourselves into producing a fuel, either adapting to newer technologies where we will be able to convert into products. And on the transportation side, we are actually committed on terms of EV and hydrogen. Many cement companies have already committed about EV 100 by 2040. And many companies have wanted to use hydrogen in the kiln as a fuel. And also, instead of air, we would like to use oxygen. Using hydrogen and oxygen in the kiln, we will be able to eliminate the CO2. And only we get the pure form of CO2 coming from the limestone, which will be economical to build a carbon capture plant. So this is one of the idea where we are actually working, and the Indian cement industry is funding a lot of startups who are working on carbon capture and producing green hydrogen, and also methanol and ethanol. So these are the areas where I feel that cement industry and paper industry can work together in terms of any innovation. The advantage what you have is that your product is recyclable. Unfortunately, our product is having a not recyclable because the cement and concrete, what cement is a binder, concrete is a product. We cannot recycle it until the shelf life of 60, 70 years or 100 years is over. Now we have started using the construction debris to produce the aggregates and fine sand, and also activators where we can convert the demolition waste also into cement and prefabricated products of concrete. And in terms of the use phase, I think most important is that when you do the entire manufacturing of cement and concrete, huge amount of CO2 emissions are coming in the process. Use phase, whether we can actually reduce the energy consumption of the building, because the buildings contribute close to 40% of the carbon footprint of the nation, and out of which embodied energy is only 17%, and whereas 23% coming from the use phase of the heating and cooling requirements and lighting requirements of the building. So there we are attempting on where a transparent concrete which allows the natural light to come in. Another one is the insulating concrete which will actually reduce 70% of cooling requirement of the building. These ways where we can actually reduce the footprint of the use phase footprint of the buildings. So that's something which we are actually trying to explore, catalytic concrete. And also the concrete supports the green growth. And in the process that where the entire surface area of the concrete, where we can actually create a type of mass which will absorb the CO2 from the atmosphere. I think due to paucity of the time, I feel that our chief guest is waiting. I would like to conclude here, but one thing I'll say that I will be here for today, and we can definitely offline we can discuss. But there is a huge opportunity for the collaborative work and also to support startups who are working on the green space, whether it's a transportation or carbon capture, green hydrogen, and production of green chemicals, or whether it's production of the fuels required for the entire industry. Thank you.